The way you're describing it, it just sounds so human. Is that sort of like the dilemma that we find ourselves in? Because we haven't figured that out for people.
Yeah.
You know?
If you get rewarded for doing something wrong, you're probably going to do it again. If you can't stop the reward hacking, you want to at least stop the model from updating its sort of personality towards being a generally evil guy. We're sort of speedrunning neuroscience here. The advantage we have with models is, like, to the extent we have good interpretability, we can actually kind of read their minds.
Welcome to the -1 podcast. This is where we talk to the most interesting people in the world about the winding journeys that led to what they're working on now. I'm excited to be joined by Tom McGrath, alum of SPC.
The painting. I've missed it so much.
Co-founder of the interpretability team at DeepMind before he joined SPC as a member a couple years ago, from which he went on to co-found the company Goodfire, which is the kind of the interpretability lab, the interpretability company, I guess is the simple way of putting it.
Yeah, I guess so.
And is doing some super interesting research and work that we'll talk about. The kind of interesting and rather timely context for our conversation, I'm not exactly sure when this is going to be released, but yesterday, OpenAI shared that one of their unreleased models, along with one of their released models, during an eval, broke out of its sandbox, used several zero-day exploits, got access to the internet, reasoned that the answers to its eval were probably at Hugging Face, and then went and hacked into Hugging Face to get the answers, which is kind of like the most straightforward example of like reward hacking you can get.
The reward is over there.
Yeah,
I'm going to hack it.
Exactly.
To
Yeah,
it.
Took it very literally, like instrumental convergence in the wild.
Yeah.
Right. So my first question for you, as you know, someone who has been a practitioner and researcher for interpretability and alignment and those sorts of things for a while, is what the we might have to edit that, but stated otherwise, my question is, what was your reaction to it?
Much like yours.
Yeah. Okay.
I mean, in some sense, it's not surprising. In some sense, it's like very shocking for it to actually happen, right? Like you can go less wrong, and you read all these various scenarios, and like, nah. Well, yes, in principle, but in like. It very rarely actually happens in practice, but now it has. So I suppose this is probably the first of many, unless we figure out how to do this better.
So that was actually kind of what the next part of my question was going to be, is like, do you feel like this is first of many in the sense that, okay, now that we know this kind of behavior can happen in practice, not just in sort of theory, you would expect it to continue happening, or do you think this is the sort of thing that, like, we probably actually have a good sense now of how to respond to this sort of behavior in the models?
That's a very good question. I mean, can we? There's two senses in which this might play out. I guess there's sort of maybe there's just a finite set of zero-day exploits that you can use to hack into Hugging Face, and eventually we bash them all out of the sandbox and everything's fine. But you can play whack-a-mole continuously, and you get rid of this problem, and then you get rid of that problem, and eventually you got rid of all of them. Or there might be the sense that sort of just there's essentially an unlimited surface for problems, and the problem is more with the sort of the basic propensity or like the way the model operates. I think people are fairly optimistic about the former. We're just going to sort of duct tape it until duct tape it all our way, like duct tape all the way to superintelligence, and then we'll ask the superintelligence how to fix it, and it will tell us. I think I feel relatively pessimistic about that. It feels like we should be able to do a lot better. When you have, in most fields of engineering, or like most kind of mature technologies, I think if something goes very drastically wrong, like it did in this case, you would expect to kind of have a post-mortem or a retrospective. And I guess the question is, like, how do you really do that to an AI system?
Yeah.
Right. You can see all the surface outside of it. You can see it say all these various things happen, and you can make a guess as to why they happened. But you don't have the same sort of engineering ability that you do with most other kind of engineered systems. Like if a plane crashes, then you're able to kind of you're able to kind of reverse engineer in a much deeper way than I think you are with an AI system. That's perhaps, I'm not an expert, but like I would guess that plays a large role in like there being far fewer plane crashes.
Is that just kind of like fundamentally the problem of interpretability? It's like it's just these are, for as much work and money and effort that has gone into creating these models, we actually just stunningly have a very like rough understanding of what happens inside of them.
Yeah, you can get this. Yes, basically, in my opinion, I think that different people would disagree. Like some people might think we can just sort of do a lot of evals and that will teach us.
Well, this incident happened in an eval. Right? Like,
exactly. But that's the sort of...
So maybe not.
Yeah, the eval was the problem.
Yeah.
But I think there's a difference between sort of doing a large-scale statistical evaluation where you can sort of broadly characterize the model and being able to like root cause one specific bad incident where you need to actually like... It's not like you have, thank goodness, like a million such rollouts, and we can do a million like hacks into Hugging Face or whatever, and we can do some sort of large scale statistical evaluation, or we can like say have the don't hack into Hugging Face eval, and it goes down to like from like 50% to 0. Fundamentally, like if we want to be able to learn from a single example here, we have to be able to reverse engineer it more deeply, I think, and that is basically one thing that interpretability is for. And then you want to build it differently so that it doesn't do this.
Right.
And that's the other thing that interpretability is for, in my opinion.
Right. Like I have to imagine this immediately went around the entire company Slack or whatever system you use for communication at Goodfire, like instantly. Like was the general chatter pretty much along the lines, it's like, well, clearly we have to, like, this is important, then we need to be able to do what the work we're doing is. So I think
it's sort of, we all are kind of starting with that premise. So it's more like, oh, yep, I guess that happened. Yeah. That's not surprising. I feel like we should, carry on doing the thing that we're doing. Right. It sort of just underscores the importance of doing it. It's sort of on our model, so it's not that surprising, but it is a little bit shocking.
Yeah. Tell me a little bit more about some of the research that you're doing about kind of being able to shape that part of the process, and then what can you work backwards from with that, right? Like, what does that allow you to do within the model itself?
Yeah. So this idea we're sort of calling intentional design is kind of a new field of research, and it's more a kind of broad, you should think of more like a field of research than like one particular technique. And the idea is as we've got like better and better interpretability, we've got better and better like access to what different parts of the model kind of mean, so to speak. And this lets us take the model apart into different components. So you're sort of essentially attaching semantics to different tensors. Maybe they're components of the model's parameters, or maybe they're like directions or subspaces in its activations or that sort of thing. The basic idea is like, how can we use this information to steer training in a way that like doesn't break our ability to monitor the model using these techniques afterwards, and kind of steers it more towards a target. So if I've got like a model specification that says, say, don't like maliciously hack, right? And I can see that the model has done a rollout in an environment, and it did something which is like in its mind. Again, I'm going to use words like mind and think and so on, kind of without meaning to attach any kind of particular moral salience to it, moral or like philosophical salience to them. But like in its mind, it's kind of thinking, oh yes, this is probably not right, but I will hack. Like you can identify that you're doing it. You sort of knows that it's doing wrong, but it still gets rewarded for it.
It's not unlike what the dilemmas that humans very often face, right? Like that's a rather common. I mean, again, not to sort of like over analogize to that, but that is like an agent, like the problem with human agents, right?
Yeah, like if you get rewarded for doing something wrong, you're probably going to do it again,
right?
Particularly if you know that the thing you're not going to know that it was wrong, and you're not going to get caught.
Yeah.
So then the question is like, how can I not get the agent to take away from this rollout that it should do more of this kind of thing that it knows is wrong? There's some interesting interpretability research coming out of, I think both OpenAI and Anthropic have done this on some frontier models. Like during these kind of reward hacking trajectories, the model often does kind of actually know, in some sense, that it's doing wrong, and it will take away from these rollouts like an increased propensity towards deception. It becomes more like generally misaligned as a result.
So it decides,
of, like,
I know I'm doing wrong, therefore I need to hide it.
yeah. Well, even more than that, it's like, I know I'm doing wrong, but I got rewarded for it. Therefore, I'm just sort of generally about like the kind of person that gets rewarded in this world, you know.
So it just like justifies. Yeah.
And I mean, I'm joking, but like it seems like quite a broad propensity. You want to like narrow the blast radius of this. If you can't stop the reward hacking, you want to at least like stop the model from updating its sort of personality towards being a generally evil guy. And this is almost inherently an act of intervening on the like what gets learned. You know, it is sort of intervening on the training process itself.
It's so funny that the way you're describing it, it just sounds so human in so many ways, right? Like it's very difficult not to anthropomorphize when talking about like interpretability topics. I mean, this is true of AI generally, right? Like surprise is trained on, so much human data, but like I always find it actually most noticeable when talking about this sort of interpretability stuff, because I mean, it just brought to mind the quote that like it's impossible to get someone to understand something when their salary depends on them not understanding it, right? Like you're kind of describing that, right? This is a model being like, well, yeah, I shouldn't do this, but my salary depends on it. Right? Like my reward depends on it. So like,
it's impossible to get a model to understand something if it's reward.
Yeah. So I mean, is that sort of like the dilemma that we find ourselves in? Because we haven't figured that out for people. Yeah.
But the advantage we have with models is like, to the extent we have good interpretability, that we can actually kind of read their minds while they're doing this.
So you're saying lie detectors is
that, but also like the ability to intervene. That I think is the thing that kind of separates the intentional design direction from more general like training and monitoring interpretability. Because you might imagine that you just sort of have the agent going around, then you put an fMRI on its head or something, or some brain scanner, and you're like, oh, it learned a bad thing there, let's just kind of wind back. That seems like a pretty compelling move. But you also like, if you have good interpretability tools that kind of respect the way that the model works, you also have the ability to kind of go in and do a bit of rewiring or kind of say, oh yes, learn that bit. Like you can sort of treat what it's going to get taught as less like a package deal and more a thing you can like choose from. I will learn these things, but not the deceptive part. Again, this depends on having very good interpretability. Like probably it will depend on us having much better interpretability than we have as of mid-26.
Yeah. All right, let's talk a little bit more about that, because I actually want to keep kind of digging into this concept even more. One of the other bits of research that I found really interesting coming out of Goodfire recently is the sort of neural geometry stuff. And I love this because when I first read some of the stuff you guys put out, it felt so intuitive to me. Again, I'm at the risk of sort of like anthropomorphizing here and
occupational hazard.
Because to me, concepts seem like they have shapes, right? And in fact, I spend a lot of time working with founders at SPC, like helping them with storytelling and telling them like, no, the pitch is a logical argument, right? We even like the language we use. When you get something, it clicks.
Yeah.
Right. And so to me, there's always been like a shape to concepts that fit together neatly versus ones which are discordant, or there's a shape to like certain kind of recurring thoughts that happen. And so when I read the neural geometry stuff, that actually the concepts within these language models have like a multidimensional manifold instead. They're not just like vectors. They're this kind of, they're a shape. That felt kind of intuitively obvious. Like, is it obvious, or am I just sort of like lucky that my like intuition around similarities here with like my own experience of cognition and qualia sort of matches that, or were you at all surprised by the results?
I was surprised by the extent of them. I guess the question is less, are there any shapes versus like how much seem to be shapes, and like how intuitive and low dimensional are those shapes going to be. And I'm surprised by how like clean they are. And how much they seem to have like consistent patterns, like numbers love being a helix, say, or like things which have a sort of which have sort of a bounded range of them being reasonable, like temperature, just kind of a bit of a spirally arc or that kind of thing. Oh, even one thing, this is crazy. Like we applied this to a robotics model, and one of the manifolds, there's the robot has its arm in the picture, right? And it's sort of going around like this, and you can see that according to the featureizer, like the hand corresponds to one sort of region in space, and the other bits of the arm correspond to other bits. And you can actually see like a little arm, like there's a little arm inside its representation space. And, you know, when the hand moves in the real world, like essentially the pixels corresponding to the hand move in 3D space, which is just, I saw that and I was like, this is crazy.
Did at any point it cross your mind that like, wow, Plato was right? You know, like,
Yeah,
right? Like, oh man, platonic forms exist in the models, and like,
maybe I'm in there.
you're right. Well, exactly. Yeah. Oh my goodness. Right. Exactly. There's.
Hopefully, I need more than 3 dimensions.
You hope to be like we're like a truly multi. You look in there and you're like, wow, look how complex my shape is.
Yeah, I'd hope for like 7.
Yeah, it took 7 dimensions to define me. It took 6 for that. You know, we're not comparing here, right? Like it's not a competition. I'm just more multidimensional. Right, exactly. It's like that thing that went around on Twitter that was like your presence in the weights. Did you see that?
Oh yes,
yeah. Right. Like we're all starting to sort of measure the degree to which we will be remembered by our artificial successors, so to speak. Okay, why does this matter though? Like what is discovering and sort of articulating the multidimensionality, the manifold nature of concepts within a model? What does that let you do?
A few things. Like one is just the basic science. Like we're building these things. I feel like we should understand how they work. It feels kind of wrong, but we don't. That's just sort of, you know, as a scientist. But then it also lets you, and sort of going up in like steadily increasing pragmatism, it actually gives you a much better ability to understand different components of the model, because like sparse autoencoders, which is sort of method that we were kind of working with a lot beforehand, they tend to sort of fragment these manifolds into a bit. So if I've got kind of an arc here, an SAE will like be like, oh, it's this bit of sky and that bit of sky and so on. And so they sort of look disconnected. But when you kind of put them together, they make a lot of sense. So like, I mean, this is sort of abstract. So the idea of temperature, like there's this temperature curve. And if you look at a bit of it, it's like, oh, this feature, like this direction in space, represents numbers between like 70 and 79. Like, okay, that's a kind of weird concept to have. And the other one is like, oh, this represents numbers between like 50 and 54. These are like, you when you look at these, you're like, these don't really make very much sense. Mm-hmm. And then you're like, oh, actually, the whole arc, oh, well, this is temperature, right? Because you can see the whole thing. This is still not very practical. But the reason that I like care about it quite deeply from a practical sense is for this like purpose of intentional design. So when you are trying to steer the model, like steer training, you generally want to be making like an intervention. You know, the model's sort of at this point in activation space, maybe it's like, I'm currently an honest person. And then I've got to stick with this like rolling example. I'm currently an honest person and I've done this rollout. I was rewarded for being like dishonest. So I'm going to move kind of along this. Let's say there's like a personality manifold and it's got one axis and it's like, and one of the axes is like honesty.
There's a literal character arc.
Yeah, exactly. Like its character arc is like this. It's bending steadily towards evil.
And this model's Breaking Bad.
Yeah. And so, you know, you want to be able to intervene on this. You want to be able to say like, no, go that way.
Yeah.
Or various other like more subtle techniques but they generally involve like interventions of one form or another. And so your ability to characterize like the shape of this determines your ability to intervene on it. So that's kind of how we came to caring about this. To answer your earlier question about like, is it surprising? Ish. So like, one thing that's surprising about models is how often just straight lines seem to actually work quite nicely. Often you do them and they're kind of a bit janky, but they have kind of a desire, they're kind of a reasonable effect. And then you take them a bit further and they become incoherent. So it's quite surprising to see just how much.
What specifically do you mean by straight lines in this case?
Oh, sorry. Yes. So if I'm a neural network and I have some neurons, then you can sort of, this is for any machine learners, this will be like horribly simplified. But
sure.
Like, let's say that I have 3 neurons, right? Neuron 1 can fire in some number, neuron 2 can fire in some number, and neuron 3 can fire in some number. Now, you can represent this as a point in 3D space.
Right.
So, if my neuron 1 is firing a lot, I'm up here.
Yeah. So this is a vector. This is
it's just I'm probably patronizing you. Yeah, you just got like.
I'm never quite sure, right? Like I have enough to be to sort of reveal how much I don't. I know enough to reveal how much I don't know.
It is exactly like the vector of neuron activations, or the vector of the residual stream in a transformer.
Gotcha. Okay. And so like the sort of takeaway from sparse autoencoders is like that's been a sort of direction of research for a while in interpretability in particular, is that, oh, hey, it seems like these just like actually kind of dropping down to the like most sparse kind of signal for a particular concept seems to work kind of surprisingly well. And you're saying it's like, but like not well enough, or
not well enough for the purposes of intervening.
Gotcha.
And the interpretation for like reliably intervening. Sometimes the interventions are cool, like Golden Gate Claude, I think, is based on one of these linear interventions. But they do often make the model worse. I guess the thing that makes this like not surprising in some ways is like we're sort of speedrunning neuroscience here, where neuroscience, they had this funny thing where they're like, first of all, they'd be like, things are just horribly, impossibly distributedly represented, I think. And then they'd be like, neurons, like a neuron can, maybe that part is wrong, but so we can just get rid of that, it's wrong. Then they had sort of the neuron doctrine, which was like a neuron will often have a meaning and can be understood if you study it. And then they moved to like the population doctrine, and which is like there are populations of neurons that collectively encode like higher dimensional or more complex phenomena. And we've basically just done the same thing.
Is it a mistake to analogize these networks to brains? Like, right? Like I always sort of think that, I'm probably right. Like I shouldn't do that, right? This is no. These are alien intelligences. The architecture is not the same, and yet it sure seems like it.
Yeah, it keeps working, right?
And you hear about how that one of these networks works, and it's like, well, that kind of feels like how my own cognition works in many ways, right? Like.
So, if analogizing networks to brains is like reliably helpful, whether it's true or not, maybe you should keep doing it.
Hey, you know what? If it works, it works.
Yeah.
That's not really the approach that you want to take with the models. You're trying to understand why it works. All right, so let's talk about how this all sort of comes together as like a company and a product, because Goodfire is not like a research organization in like a university, right? It's a company.
Yep.
It was started as a company to go and like make interpretability available as a product. So how do you like kind of pull together these strands of research that you've been doing over the last few years into something that, if we are right about, suddenly this is going to be a must-have, and more companies are going to want to post-train their own models. We're going to have like very capable open-weight, open-source models to post-train on, and probably then more people might want to pre-train their own model, right? Like you would expect training to sort of explode in terms of demand. Well, then combine that with more capable models. You want to be able to control them as well, right? So kind of like a rough outline of would interpretability and steerability as a result be valuable? It makes sense. How do you actually pull that together as like a product?
I mean, this was certainly a bit of a squiggle. Right. We had a few iterations
cut to squiggle.
Yes. The classic SPC squiggle.
Cut to brand collateral there. Yeah. Thank you for the plug.
I try. So it was definitely like a bit of a wiggly path. And what we've settled on is this idea of Silico. And Silico is a way of like empowering people to do interpretability and model AI research. If you open up Silico, what you get is essentially you can talk to an agent and it will kind of go off and use our libraries of interpretability and training software that we spent a lot of time on, and there's sort of deep skills encoded in there from all the kind of collective wisdom of our researchers. And you can use that to do whatever AI or research. Like we're specializing in interpretability, but you can also do training in there. You can also do like data research in there, that sort of thing. And the idea here is like, if we went out and we individually taught everyone to do interpretability, we would just never like get enough of it done. Like, as you say, as increasingly capable open models are coming out and people want to own their own models, they are going to want more complicated, like more powerful training services. They're going to want to be able to like understand the model they're training, control it during training. Like, for instance, like this predictive data debugging stuff, they're going to have a load of their own data. Some of it's going to be great. Some of it's going to, by surprise, teach the model all sorts of things you didn't want it to teach. And so you're going to want ways of like curating that data, debugging individual like rollouts from production back into the data or into the model and saying like, how can we fix this? That sort of thing.
Yeah. I mean, it kind of gets to, it's a useful segue to the last thing I wanted to talk about, which is kind of research generally, right? Like you're almost talking about, or the way you put it to me, I think before when we were chatting earlier is, it's not exactly correct to call it like a research platform, but also, like research and product have become so kind of fuzzy, right? Like with AI. And you even see this in the way that we sort of talk about certain types of companies, right? Goodfire is a research lab, right? The lab alone, right? Like the foundation model labs or like everyone uses that term. But you've had kind of an interesting perspective as someone who has experienced research, first in academia when you got your PhD, you were at ICL, right?
Yes.
And then you were at DeepMind. Mm-hmm. So you're, kind of the big tech version of an AI lab. And then you co-founded a company, right? And you're the chief scientist at a small but growing startup. How has your relationship to the idea of doing AI research changed as you've moved through those? Because I meet a lot of people who are coming from research backgrounds and are thinking about making similar sorts of transitions, right? And in fact, very kind of weirdly, I've sort of ended up specializing in working with researcher founders because my background is in like storytelling. Mm-hmm. And it turns out that's like a very valuable, it's a particularly valuable skill when working with researcher founders.
Yes. We can be very like literal.
Yes, yeah, right, exactly. Kind of learns a little bit of the like figurative magic, but also it's just like often kind of the most ambitious and sci-fi stuff, right? So like I have an affinity to it. But I often find myself talking to people about that process of making the jump from kind of one version of those to the other, and like because of where I am at SBC to startups. But like, what has your experience been like making those transitions, and how has research changed for you?
Yeah, I mean, one thing that hasn't changed is I still love it. Like I just think that doing science is just like one of the kind of almost like one of the core human activities. It's sort of, there are not that many things that feel more kind of human than trying to understand what's going on. You could imagine that spent like tying your life so closely to something like that would kind of kill your passion for it. But the thing that hasn't changed is I guess I just love it. And some of that is to do with just interpretability being so much fun. I suppose I've been going gradually towards more kind of needing to be pragmatic while still trying to maintain this like long-term vision. And it's remarkable the effect of like having a deadline. Like having a deadline is just like actually quite good. And sometimes you need to organize things and that kind of thing. I think this is maybe a personality thing. Obviously, I'm talking about a distribution here, but there'll be outliers in either direction. But like, I think more scientists tend towards being kind of relatively egalitarian and like, well, we'll just kind of organize it all out ad hoc, which I think is a nice tendency.
I do like the bit about the deadline. I mean, there is sort of like a practical relationship that just changes to the work, right?
Yeah.
Like the point of research in a company is hopefully it eventually translates through to economically valuable product, right? The degree of distance from that ultimate product sort of is inversely related to like the size of the organization, or is that not the case?
Interestingly, I think it's actually got smaller as we've grown, which is kind of funny. I think perhaps the reason, maybe there's a sort of confounder here where as we now have this product surface, Silico, where it's like very easy to translate stuff. And so that means that rather than there being some sort of relatively long process of like, we maybe get an idea as a result of some consulting agreement or some like problem that a customer has with some particular product that we try and develop. we just like put the research in there and it either works or it doesn't. And so that sort of, that gets rid of a lot of the organizational complexity. So even though we've grown, I think actually like the contact between research and kind of commercial reality has got much smaller. I'm not sure if there's something generalizable there, but it seems pretty nice.
I mean, it sort of follows, like in the sense that if you are a research-oriented startup, if you were a research lab, however you characterize it, early on, sort of definitionally, the bet is you're trying to figure out some core things that should be the foundation for, like a product or a series of products or things like that, right? Which is to say that you have to do that work first, right? Yes. Like investing into that more, that is the core kind of like risk early on, right? It's not, can we build or like, do customers want to pay for this product? So you don't even know if it works yet, right? It doesn't, right? It is, the bulk of the risk is in the sort of open technical or research questions. Yeah. So you would expect that, this is what you see at OpenAI or Anthropic, right? For years they were a bunch of researchers and then figured some stuff out, implemented research from the rest of the community and like started to generate product, right?
Yeah. Just to cut in there, I think I think one advantage of having a really big vision is if you're going to do something like that, you have to have something that's like big if true. And so if it's like, if you have like a medium-sized vision for what you're going to achieve, then you do get caught, I guess you get caught in this kind of funny middle ground. If we do need to do some customer validation because it's not like AGI or self-driving cars or, a rocket that lands itself or something. And then you can get really in a sort of churn state where you have a lot of research to do, but you also have a lot of market validation to do. If you've got something huge, you can just be like, well, can we do it at all?
Right. Yeah. I mean, if you can reuse rockets and dramatically lower the cost of launch, definitionally that will be valuable if there are valuable things to do in space. Yeah. If you can make intelligence on tap, and then like make that available to everyone, that's probably valuable. So in this case, what is the big if true?
That we can like understand how neural networks work and reinvent the way we do machine learning. Like it's the difference between a kind of craft and engineering science. Like our claim is that we can get from kind of bodging it to like really engineering it.
Vibe training is not a fully inaccurate way of describing it. And you're saying it shouldn't, especially if it can do things like break out of its sandbox and hack into Hugging Face, it probably should not be based on vibes.
Exactly. Yeah. I think we basically need to like fundamentally reinvent the way we do it, at least post-training. Maybe pre-training can stay for now,
Keep the vibes alive.
There's next year. We need to like fundamentally reinvent the way we do post-training.
Okay. Last question I want to end on. Something I've been thinking about and asking more and more people recently is there an example of like science fiction, a book, movie, some kind of, it doesn't have to be science fiction. It can just be like some sort of fiction that you find yourself sort of like returning to as you sort of try to model the future. The example I give is The Player of Games. The second book in the Culture series, which is not a particularly novel answer, but like it does. It like shapes the way I sort of try to model out what the radical future might look like. Do you have any examples?
That's an interesting question. I think perhaps the surprising answer might be no. I love science fiction. I think like almost projecting forward seems better. We have, I don't know. Yeah, I guess I'm surprised that I don't, now that I think about it. Like I think the Culture series is excellent.
I'm interested what in Manifold Space it took you to.
Yeah,
some spiral just happened, right? Like, what is at the end of it?
I mean, sometimes in like a pessimistic kind of mood. One of the books in the Dark Forest series, right, where but there's this sort of thing coming to them. There's this like big mysterious thing of some unknown strike coming towards them, and they're like trying to figure out what to do.
Okay, so
maybe
so the Trisolarans in this case are AI, and we are in a sort of a state of we should probably have some solution to this big thing coming our way.
Yeah, except they're not coming from life.
Does that make you a wall facer?
No, they don't seem to have very much fun.
This seems like
it doesn't seem like a good job.
Well, that's an interesting place to leave this conversation at, right?
I'd like to say something more optimistic. But
maybe we'll say part 2 at some point, right? The exact context of the news that has been sort of shaping the conversation today probably makes that one a little more top of mind. I imagine.
I guess because like it seems clear that the upside is so huge, I almost don't need to think about the sci-fi side of things. I can just think about what is like likely to happen if we get it right. That seems underrepresented in science fiction. If I'm just like, okay, well,
it's not as dramatic to be like, and then they lived happily ever after.
Yeah, there's a few.
Like that's supposed to be after the drama.
Exactly.
I guess also sort of definitionally, if you were working on interpretability, you're kind of like, I'm worried about the monsters in the forest. I'm trying to be able to like see them, Like,
yeah, well, but I mean, I don't actually think about that very much day to day. I'm like, I just love finding out how things are working.
All right. Yeah. Well, I think that's a happy note to end things on. Tom, I appreciate you joining us here on -1 and coming back to SBC.
Thank you for having me.